Welcome to night 2 of the acid-base homework. Tonight your homework is page 3 and 4. Tonight's homework is very concept-based. There's not going to be very much math, so you'll see me pull in and reference the notes. For the first part, they're giving you properties of acids and bases. This can be found in the section labeled Properties of Acids and on page 6 of the notes, where we talk about the properties of bases. So I'm going to go through and highlight the words that will give you the big clue. We talked about for sour, that's the way acids taste. Like lemon juice is an acid and it tastes very sour. Bases taste bitter. These are going to be things like cocoa and baking soda, and things that you've put into your mouth that perhaps you think, oh, this tastes awful. In the solutions unit, we learned that an electrolyte is something that carries an electric current, which also means it would have a positive and a negative. If you think about acids and bases are both going to be made out of a positive ion, acids being hydrogen, and a negative ion, for bases being hydroxide. So both acids and bases would be electrolytes. You would continue the following questions to answer the question based on the clues of whether it's going to be an acid or a base. For the second part, you're naming and formula writing. We learned in naming yesterday that hydro indicates that there's only 2 elements involved in this acid. We know that acids always start with the letter H, so we just have to figure out from this root word what the other element is. When we pull in our periodic table, we'll see the nonmetal that has selene would be selenium, which selenium has a -2 charge. So if hydrogen is +1 and selenium is -2, the final formula would be H2Se. For the next one, we can see that this is a polyatomic ion. ClO3 is going to be one of our polyions. So we'll pull out our chart and look for ClO3. It's called chlorate. Whenever we have an ion, we talk about how ATE turns to IC. So this is going to be chloric acid. So ATE, polyatomic ions, turn to ic. And later on, if you hit something that ends in ITE, it changes to us. You can identify that something is a base because you will see hydroxide. This is how Arrhenius defined a base. You would still do the same crisscross applesauce, whatever your teacher calls it, where you have the barium has a +2, hydroxide is -1. Most students forget that hydroxide needs to be in parentheses. Without parentheses, it's just saying you have 2 hydrogens, but this is actually demonstrating you have 2 hydroxides. You would continue this section by either naming or formula writing, being careful to note that hydro is only when there's 2 elements. I will demonstrate one more. This is nitrite. And we just said that ITE changes to OUS. So this is nitrous acid. Probably thinking of Fast and Furious here in the word nitrous. So you would continue that section in that manner. For the following, you look at the equations and you try to figure out if it's an acid or a base. Pretty much the dead giveaway for hydrogen or for acids is that you'll see H with a positive, whether it's hydrogen ion or hydronium ion that has joined a water molecule. So if you see H3O or H+, you would call that an acid. If you see hydroxide ions dissociate, those are going to be base, or we call it basic. For the scientist, you look up on your notes that Arrhenius stated that all acids produce hydrogen ions and bases produce hydroxide ions. We will expect that you know the difference on your test. You can find it in your notes right here under acids and bases. So bases are proton acceptors. For this section, we give you more clues about acids and bases, and you just have to identify acid, base, or neutral solution. Keeping in mind that the pH scale from 0 to 6 would be considered an acid, trying to stay consistent with acids being red or pink. 7 is going to indicate a neutral solution, and 8 through 14 is going to be a base on the pH scale, which we will talk much more about tomorrow. Ionizes in water. The word ionize has to deal with dissociation. It breaks apart into positive and negative ions. And we talked about on the previous page that that would be both acids and bases. If the H hydrogen concentration and the hydroxide concentration are equal, that solution is said to be neutral. Okay, students tend to still have a hard time with this greater than, less than concept. So a lot of students have told me the alligator's mouth is here, so this is greater than, so the pH would be less than 7. So that would indicate an acid. Again, this is saying the hydrogen concentration is greater than the hydroxide, which would mean that it would be an acid. Again, some of these clues, you're going to have to look at your notes. You absolutely will have to know that acids turn litmus paper red and bases turn litmus paper blue. The rest of these can be found within your notes, or you can ask your teacher. The last part of tonight's homework, you are identifying each as either an acid or base based on their location on the pH scale. Let me remind you that we said that 1 to 6 is going to be an acid. I'm going to say that 7 is neutral, and that 8 through 14 is going to indicate a base. So you look at where it is on the scale, and you just write whether it's an acid, like lemon juice, or glass cleaner. Honestly, glass cleaner has ammonia in it, or, this is really a hard one because technically now they make vinegar Windex for granite countertops, so this is kind of vague. Let's assume this glass cleaner is ammonia, and we would make that one a base. But they do technically sell glass cleaner that is a vinegar base for granite countertops, because you're not supposed to use bases on granite countertops. It eats away at the sealant. So if it were a vinegar-based glass cleaner, this would be an acid. You look on the scale, The most common missed one is bleach. People assume because bleach is dangerous that it's an acid, but bleach is actually a strong base. Okay, bases can be just as dangerous as acids, depending on their concentration and their strength. Thank you for joining me for homework night 2. Signing out.